Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to be an introductory video about the mathematical concept of a function. Okay, so here's in a mathematical sense what a function is, right? A function is a mapping, I really like that word there, from a set of elements called a domain to corresponding elements that are in a set called a range. Right? So important words are mapping, okay, a set called a domain, and a set called a range. Okay. There's a very important mathematical property of a function that each element in the domain can be mapped to only one, and that's really important, element in the range. Whenever you have a single domain element that gets mapped to two or more range elements, then the relationship you're looking at is not a function. So I wanted to go through kind of a really generic example here that demonstrates what a function is. And this example is coming from the show Big Bang Theory. So Sheldon Cooper in the Big Bang Theory. If you're familiar with this, great. If you're not familiar who Sheldon Cooper is, that's fine too. The idea is it's a person that is absolutely rigid about his life and eats the same food on any given night, okay? So the eating habits of Sheldon Cooper we could actually describe as a function. So we have a set of elements in our domain here. And in this set here, the elements are going to be these 5 days of the week. Now, why not 7? Just to shorten up the example. I could have included 7, but it doesn't matter. So we're just going to talk about what Sheldon Cooper eats on Monday, Tuesday, Wednesday, Thursday, and Friday. Now, it's important to know if you don't know the show. When Sheldon eats a food on Monday, he eats the exact same food every single Monday. So these days, Monday, Tuesday, Wednesday, Thursday, and Friday, these would be elements in our domain. Now, the potential foods that Sheldon would eat. And I just put 3 foods over here to the right here, pizza, fish, and Thai food, just the 3 things that came to mind. This isn't reality from the show, but the first thing you might notice is it okay that there's 5 elements in the domain and only 3 on the right, which, by the way, is our range? The answer is yes. I could have made up more or less. It doesn't really matter. They don't necessarily have to match. Right? And then what I'm going to call the function here is what Sheldon eats every night. So if on Monday night Sheldon always eats fish, then I can write that out in function language right here. F of m is equal to fish, meaning that on every Monday, Sheldon eats fish. And similarly, imagine that every Tuesday, Sheldon eats pizza. Then we can write this mathematically and say that f of Tuesday is pizza, and f of Wednesday is Thai, and f of Thursday is pizza again, and f of Friday is Thai food again. Now, right now you might be wondering, is this okay? Because right now we have 2 different days getting mapped to Thai food, both Wednesday and Friday. And the answer to that is yes. It's completely okay for 2 different domain elements to get mapped to the same range. That's not a problem at all. Right? And if I actually kind of draw my mapping here, like Monday is getting mapped to fish, Tuesday is being mapped to pizza, Wednesday is getting mapped to Thai food, Thursday to pizza, Friday to Thai food. Right? Now, here we have 2 different domain elements getting mapped to the same range element. That's not a problem, right? That does not negate the fact that this is still a function. So this is a function, no worries. Now, here's an example of what would have turned it into a non-function. If Sheldon had both Thai food and pizza in the same night, then this relationship would no longer be a function. So for example, on Friday night, if he had pizza and Thai food, not a function then, because we'd have 2 elements in the domain. I'm sorry, because we'd have 1 element in the domain, Friday night, getting mapped to 2 different elements in the range. And that would disqualify this relationship here as a function. So that's a little bit about what functions are. In general, they're mappings. Now, in an algebra class, the functions that you're going to consider are going to be algebraic functions in nature. So we're going to take a look at this one right here. And here's some function. I just sketched it. Now, the actual equation for it is not important for the discussion. This is some function. I'm going to call it f of x here. That's standard function language. And what that means is that the function value depends on what x is. Now, the function values, the f of x's, for all practical purposes, these are the y values. So if I were to pick a spot like right here, like this, let me color code it here. Now we'll make it blue. So this spot right here, x is 1, 2, 3, 4, and y is 1, 2, 3, 4, 5. So our function here maps 4 to 5. In math language, we would say that f of 4 is equal to 5. Or in other words, this is on the point 4, 5. Now you might wonder, does this mean that the y values are range values and the x values are domain values? And the answer to that typically is yes. So when you're looking at functions or graphs, the horizontal axis, if you call them x's, these are going to be your domain elements, and the y values are going to be your range elements. Now we're going to go ahead and kind of answer these questions. What is the domain of this function? So the domain are input values. Very important to realize. You're looking for the inputs. Basically, these are the x values. This function stops here at, let's see, 1, 2, 3, 4, 5, 6. X is equal to -6 here. That's the furthest left that I see. And if we follow this function all the way to the right, the furthest x value that we will see, let's see, is 1, 2, 3, 4, 5, 6, is 7. So the domain of this function is the interval from -6 to 7. Let me just check that again. 1, 2, 3, 4, 5, 6. Yep. And 1, 2, 3, 4, 5, 6, 7. Yep. Now you notice I used hard brackets here, right? That's because basically this was a closed dot right here. If that were an open dot, like if it were not including the -6, this would have looked something like so. Right? So I drew this. The intention was including the -6 and including the -7. So all values in between -6 and 7 are in the domain of this function. Okay, the range of this function. Now, for all practical purposes, these are the y values. And the lowest point on the graph that I see, go back, oops, come on, is here. And the y coordinate, -1, 2, 3, 4, 5, 6, is -6. The largest y value I see is this one, where that y value is 1, 2, 3, 4, 5, 6, 7. So the range of our function is from -6 to 7, including the -6 and the 7. Get this to scroll here. Oh, that ended up being kind of the same. That was just complete coincidence. -6 to 7. Probably have to redo the video here. I did not intend that, but again, these are x values and y values. All right, let's see. What are the intervals, or what intervals is the function increasing? I worded that a little better, but all right, so the function is considered to be increasing anytime when you're going from left to right, the function is getting bigger. So I'm going to color code this in red. Function's getting bigger all the way to this point about here. Right now the function is getting smaller. I'm going to leave that alone for a moment. And then the function is getting bigger from here all the way to here. So everything in that kind of cool red there, the function is considered to be increasing. So let's see, that was -6 to about -3 here. So from -6 to -3. I'm going to soft bracket that and explain why here in a moment. And from, let's see, the x value here, it's maybe about 1.4 to about, what was that, 7? 1, 2, 3, 4, 5, 6, 7, yeah. Okay, so I'm going to put, right, and from, oops, I about 1.4, give or take, to about 7. Bracket value, let me take a look at that. Oh, hard to tell in the end here. I'm going to go ahead and assume it's still increasing there. This one's a little hard to tell. Now let me talk about why I put soft brackets here and here. Because if you actually look at the slope right at this point, right, this is what's called tangent line slope. Right at that point there, the tangent line has 0 slope. So it's not actually increasing at that value. That's why this -3 here is not included in the increasing part. And same goes for the 1.4. The 7 was a little hard to tell. I'm not sure, even being the one that drew it, I'm not sure if I intended that to have 0 slope or not. I should have made that a little bit more clear, but I'm going to assume slightly increasing, ever so slightly like this. Therefore, I'm going to go ahead and include the 7 on the end of that. Okay. Next question is the decreasing. So the function is decreasing on this interval. Oops, to here. And that's about it. I didn't copy that perfectly, but that's okay. And that's the only interval that I see where it's decreasing, so I'll go ahead and write that. That was from -3 to about 1.4. There we go. All right, so that's how to tell the domain and range of a function and the intervals of increasing and decreasing. Let's take a look at the next set of questions here. Which of the following are functions? So I got a whole bunch of relationships here. I'm going to go through them one at a time. Which ones are, and discuss which ones are functions. So this animal right here, this is a function because for each single x you put in, no matter what number you put in there, put in any number you want, you're going to get exactly one y value out. So I can't prove that for every single number. I need you to just kind of take my word for that. I can't. There's an infinite number of examples, but you just have to look at it and agree. Pick any number you want for x, you're going to get exactly one y out. So each element in the domain is going to map to exactly one element in the range, and that's a function. So yes, this one is a function. Okay, second one, let's take a look at this one. So this one's not a function. And here's an example here. And there's tons of counterexamples, but let's say that y were 0. The resulting equation is x squared equals 4, which has 2 solutions, +2 or -2. And that means that if x is 2, y is 0. Furthermore, though, if x is -2, whoops, I got to go back. I'm sorry about this. It's not quite the way I wanted to discuss that. My apologies. Each domain goes to one element range. Okay, what I meant to say was this. Let's imagine that x is 0. Now I could have picked 1, 2, or 3 as well. I'm just picking a value here. The resulting equation is y squared equals 4. And this has 2 solutions, +2 or -2. So our domain element, 0, is getting mapped to 2 different range elements, and that's the big no-no. So because of that, this is not a function. No. This one, right? Every single x, try it, that you put any number in there, you're going to get exactly one number out. So this is a function. This one, I'll let you folks guess at that. We can talk about it when we're in class here. Okay? Kind of similar to this one. Pick a value of x, any single value, and see what you get out for y. And then decide if it's a function or not. See if you can get 2 different y values for a single value of x. Right? Sometimes functions are given in this form. So this set of these points, 0, 2, 1, 3, 4, 7. So the domain elements are these guys, the 0, the 1, the 4. The range elements are the 2, the 3, the 7. And you can see that each domain element is getting mapped to exactly one range. So this is a function. say yes. And now we're going to look at this next set here. A little bit bigger set. Our domain elements. And let me do these in green. Right? 1, 2, 1. Well, 1. That's fine. -3. So the domain elements are actually 1, 2, and -3. The fact that this is listed twice doesn't mean it's that there are 4 domain elements. And the range elements, right, the 5, the 9, the 7, and there's the 5 again. And this one, hopefully you've guessed it, is not a function, and because we have a single domain element, 1, that's getting mapped to 2 different range elements, 5 and 7. So in this example, f of 1 is 5. However, from sitting right here, f of 1 is also 7. This now fails the test for a function because we have a single domain element, 1 being mapped to 2 different range elements. So I think what I'm going to do is end this video right here. End of part 1. And I'll make a second video here picking up where this left off, right? I hope that this helps. Have a great day.